Welcome to AB Video 1.4F Part 2, the Intermediate Value Theorem, which I shall refer to as IVT.
Square bracket. And the very last thing in the in this section is the Intermediate Value Theorem, which I will be calling IVT. So, let's read it. If f is continuous on the closed interval from a to b, and if f of a does not equal f of b, and if k is any number between f of a and f of b, then it guarantees there's at least one number c. Now, this should say, I know the book it's wrong. It's just wrong. It should say at least one number c in the open interval from a to b, such that f of c equals k. So it sounds very complicated, but it's extremely simple. Now, I do want you to realize they're going to give you the function, they're going to give you the closed interval from a to b, and they're going to give you a value of k. You have to have all three things if you're going to be able to use this theorem and find this k, the value of x that will make this theorem true. So basically, if you look at this picture on the right, what they're basically telling you is if you start at this point, f of a, and you travel along a function, so it's got to be a function, and it's a continuous function, so you're not lifting your pencil off the paper, and you travel until you get to another closed-in dot. Remember, it's a closed interval. Basically, what they're saying is, if you start at this height, let's pretend f of a is 2, and you stop at this height, f of b is 7, somewhere between this height of 2 and this height of 7, you've got to go past the height of 3 at least once. So basically what they're saying is if you get on the second floor on the elevator and you get off at the 7th floor, you got to pass by the 3rd floor on your way there. Pretty straightforward. Okay, here's another example. Oops, except for it's not all there. That's a problem. Okay, so let me do this, and let me do blue. Okay, so let's say this function starts here and goes down here. So we have a closed-in dot right there. So it satisfies all the conditions. It is a function. The function is continuous on the closed interval from a to b. F of a is not at the same height as f of b. And there's some number k between f of a and f of b. And again, if you're going to go from this height down to this height, you've got to pass by this height on the way there. So there does exist a number c between a and b, such that f of c is equal to that height k. Okay? Now, you'll notice that the theorem says there is at least one number c for which this is true, and that could be a situation like this, where you start off at this height, I don't know, let's pretend f of a is 7, and you have this continuous function that you travel along, and you stop at this filled-in dot, and let's say f of b is negative 3. So if k is any number between negative 3 and 7, you're going to have to pass by that height at least once. Well, in this particular case, I pass by the height k 1, 2, 3, 4, 5 times. So there are 5 values of c between a and b, such that f of c will equal k. Okay, so again, just to review, they're going to give you a function, a closed interval, and a value of k. These are the 3 things you need to do. Oh, it's kind of like another trilogy. First, you need to convince the reader that the function they gave you is continuous on the closed interval they gave you, which means you've got to identify that type of function, and then you've got to say it's continuous on its domain, and you have to let me know what that domain is, so that you can conclude that this condition, this hypothesis, is true. The second thing is you have to check that f of a doesn't equal f of b. Students often make the mistake of saying a doesn't equal b. That's not what we're talking about. We're talking the height at the point a, f of a. F of a cannot equal f of b. So you have to find f of a, numerical value, find f of b, numerical value, and show me they're not equal. Finally, you have to be sure that the k value they give you is indeed between f of a and f of b. If all 3 of those are true, then the conclusion is that there's got to be at least one number c between a and b, such that f of c is equal to k. So, numbers 91 through 94 say to ask you to verify that the intermediate value theorem applies to the indicated interval. So you got to go through those three processes to verify it holds. Then, if it holds, well, they're telling you it does because they're saying verify. Find the value of c guaranteed by the theorem. Okay, so number 92, here's your function. Here's your closed interval. A is 0, B is 3. And the book is actually saying f of c equals 0. The AP and I will just say and k equals 0. Okay? Okay, so here's the verification process. First, is the function continuous on the closed interval that they gave you? Is this function continuous on this interval? The answer is yes, and you have to tell me why. You have to tell me because this is a polynomial function, which is continuous on its domain, which is all real numbers. Second question, is it true that f of a does not equal f of b? Well, here's a, here's b, here's f of x. So you have to find f of 0, you have to find f of 3, and you have to show that they do not equal the same thing. F of 0 is 8, f of 3 is negative 1, so in effect it is true that f of a does not equal f of b. The last thing you have to do is be sure that k is between f of a and f of b. Notice they didn't write it as an inequality because you don't know if f of a is lower than f of b or f of a is higher than f of b. So the question here is 0, which is our k, between f of a, which is f of 0, and f of 3? Is 0 between 8 and negative 1? The answer is yes, it is. Therefore, the intermediate value theorem holds, and there exists, this is a backwards capital E, means there exists, a number c between a and b, which is between 0 and 3, such that f of c equals k. Now remember the k is 0. F of c, you just take f of x and replace the x's by c's. Solve that equation, but only keep the numbers that are between a and b. 4 is not between 0 and 3, we can't keep it, but 2 is. You can bet that the multiple choice answers, one of them will be 4 or 2. So be careful.
And that's the end of video 1.4F part 2.